Welcome to this video on functions. This is part 2 of a 2-part series. In the first set of videos, we defined what functions are and distinguished them from relations, and then we used algebraic, numeric, and graphical methods to determine if a relationship was a function. In this video, we will do 3 things. We will introduce function notation. We will learn how to find the domain and range of a function given a set of ordered pairs, a graph, or the function in algebraic terms. And then we will learn how to evaluate a function both using function notation and also from its graph. What is function notation? Why do we use function notation? And how do we read the following expression? What does it mean? Well, quite simply, function notation looks like this. Why do we use function notation? We use function notation to indicate one variable is a function of one or more other variables. The way we read this is f of x. This indicates that f is a function of x. It's very important to understand that f of x, this expression right here, does not indicate multiplication. In the past, anytime we've used parentheses like this next to 2 variables, it's always meant f times x. But again, I encourage you to remember when we're using function notation, this is not the case. It does not mean multiplication. This notation, f of x, will take the place of our dependent variable, often represented with y, in the equation. To better understand function notation, think about how you decide what to wear on a given day. What factors do you take into account when getting dressed in the morning? You may consider the weather and what you have to do that day. You are probably also limited to wearing clothes you already own. So we could say that your outfit for the day is a function of the weather, your activities, and the clothes you own that are not in the dirty laundry. In other words, we could say outfit equals a function of weather, activities, and clean clothes. As you can see, function notation is simply a method of expressing what input variable or variables help to determine the output variable. Let's complete this activity to get a better grasp on function notation. The directions ask us to rewrite the following equations using the function notation f of x. Assume the isolated variable on the left side of the equation is the dependent variable, and the other variable is the independent variable. So first we have y equals 3x cubed plus 2. So we're going to assume that y is our dependent variable, and we're going to replace this with f of something. And that something is going to be whatever our independent variable is. As you can see in this problem, our independent variable is x. So instead of y equals 3x cubed plus 2, we're going to write f of x equals 3x cubed plus 2. Again, f of x is just a fancy way of writing y. It's still our dependent variable. Okay, next we have y equals x squared minus 7. So again, y is our dependent variable. We're going to replace him with f of whatever our independent variable is. As you can see from the other side of the equation, our independent variable is x, so we say that f of x equals x squared minus 7. Pause the video and see if you can do a few more examples without help. The next one is f of x is equal to e to the x power. What about d equals 2c minus 4? Well, we have to assume that this variable is the dependent variable because that's what the directions ask us to do. So we're going to replace d with f of something. But what is our independent variable? Well, as you can see, our independent variable is the variable on the other side of the equation. In this case, it is c. So we're not going to write f of x because we don't have x. We have a c. So we say f of c is equal to 2c minus 4. Pause the video and see if you can do the last 2 examples. Then unpause it to see if you are correct. In the next one, we're going to assume that g is our independent variable. So we're replacing g with f of something. But what is that something? Well, as you can see, m is our independent variable, so we have f of m. In other words, this is a function of m. So f of m equals 2m to the 4th power. Last but not least, we have s equals 2y. Again, we assume that this is our dependent variable and replace it with function notation. But what is our independent variable? Well, you can see on the other side, our y is our independent variable. So we say f of y is equal to 2y. Now this might be a little bit confusing because we're so used to having y be our dependent variable. but that's just sort of tradition, right? It doesn't always have to be that way. So in this case, y is acting as our independent variable. Let's look at this problem. If f of -5 equals -3, then the point blank is on the graph f. So remember, when we have ordered pairs, right, we have x comma y. So which of those values is x and which one is y? Take a minute, pause this video, think about that, and then see if you can answer the question. Well, remember, this is really f of x. So what is in place of x? Can you figure it out? X, according to this notation, is -5. So the first value in our ordered pair is -5. So then what is y? Well, remember, f of x is the same as y, isn't it? So we can say that this whole thing is y. So that means y must be equal to -3. So that is our final answer. Again, just to reiterate, this is our x value, and this is our y value. Domain and range. The domain of a function is the set of all possible inputs, or x values. The range of a function is the set of all possible outputs, or y values. Finding the domain and range of a function. We can determine the domain and range of a function in a few ways. 1, we can look at a set of ordered pairs. 2, we can look at the graph of a function. Or 3, we can look at the equation of a function. Let's begin. Let's practice determining the domain and range of a function given a set of ordered pairs. Suppose you have the following relation. Determine if the relation is a function and then state the domain and range. So first of all, what are the set of all x values? Well, the set of all x values are 6, 5, 4, and 3. So the way we write that for the domain is we write 6, 5, 4, 3. So those are the set of all x values for the function. Then let's look at our y values. Our y values are -4, -2, 0, and 2. So the range of the set of y values for our function are -4, -2, 0, and 2. Now, how can we determine if this is a function? Well, remember, if any x value maps to more than one y value, then it is not a function. But here we can see that all of our x values are unique. They're all mapping to different y values. So is this a function? Yes, it is. Again, if you have trouble just looking at a set of ordered pairs and determining whether or not it's a function, remember you can always graph those ordered pairs and apply the vertical line test. Let's do the next example. Again, the domain is going to be the set of all x values. So we have 7, 8, 7, and 3. Since I see 7 twice, do I need to write it twice? Absolutely not. I'm only going to write the 7 once. So that is my domain. Then let's look at my range, my set of y values. 4, -2, 5, and 2. So I'm going to write 4, -2, 5, and 2. Notice I'm using curly brackets to enclose my numbers. All right, so now comes the tricky part, right? We have to figure out, is this a function or not? I encourage you to pause this video, see if you can answer without me, and then unpause it to see if you are right. Well, notice that 7, 4, and 7, 5, we have a single x value mapping to more than one y values. In other words, when I put 7 into my machine, sometimes a 4 comes out, sometimes a 5 comes out. So the answer is no, this is not a function. So now let's look at graphs of functions, or relations really, and see whether or not they are, see if we can determine the domain and the range. So remember, domain, again, is the set of all x values, or your independent variable. Range is the set of all y values, or your dependent variable. So again, just to remind you, this is your x-axis, this is your y-axis, okay? So what we want to do is we really kind of want to swipe from left to right and see what is the smallest x value where we see our function and what is the largest x value. And that's how we're going to figure out our domain, okay? So if I look here, right, our smallest x value is at -3, okay? And what is our largest x value? Our largest x value is at +2, okay? So then we need to think about Well, are we including or excluding these endpoints? And if you don't remember how interval notation works, please go back and watch the videos that I posted to help you remember how that works. But basically, if we have a closed circle, that means we are including our endpoint. Okay, so anytime you see a closed circle, you're going to use a bracket, okay, to indicate that we're including that point. So that means next to -3, I need to draw a bracket. Okay, anytime you see an open circle like this, that means we're excluding that endpoint and we're going to use parentheses. So we need to put a parentheses next to 2. So that's how we write that in interval notation. How would I write that in inequality notation? Well, this is what is called a compound inequality. And the way I would write it is I would write -3 is less than or equal to x is less than 2. Okay, less than or equal to because we're including it, right? That's what the bracket tells us. The bracket matches or maps to the less than or equal to sign. And this is just a strictly less than sign because we're excluding 2 from our solutions. Okay, so now that we have figured out the domain, the x values of the function, now we want to look at the range, the set of y values. Okay, so on our graph, we're going to sweep from the bottom to the top, and we're going to ask ourselves, what is the lowest y value? Well, the lowest y value is -5, right? And what is the highest, the biggest y value where we see our function existing? And that is at +4. Okay, so that's going to be our interval notation. The next question is, are we including or excluding those endpoints? That's what we need to figure out. So again, we have -5 and +4. Because of this closed circle, we know that we're including 5, so bracket needs to be next to -5. Okay, this is actually touching 4, so that's part of the graph, so we would also include 4. If we had to write this in inequality notation, we would write it like that. Notice that both of these have this line under the equal sign, meaning that we're including both of those endpoints. All right, let's do another example. So domain, we're looking at our x values. So here are our x values. Here's our x. Okay, so the implication here, I didn't draw it on the graph, is that this is infinite in both directions. Okay, so if it goes on in both directions, is there any, what is the smallest x value? Well, the idea is it goes on and on and on forever. So there's no limit on the x values. And the way we write that in interval notation is we say -infinity to +infinity. Okay, so that is the domain of my function. Okay, if I have to write that in inequality notation, there's a few ways to do this. If you want to use special math notation, we would say that x is an element in a set of all real numbers. In other words, x can be anything. So that's what this means here. Okay, but you don't have to necessarily memorize that notation. I think almost all of these, if not all of the problems on online homework, ask you for this interval notation, so that should be sufficient. Okay, so let's look at the range, the set of y values. So again, I'll leave the arrows here reminding us that it does go infinitely up. Okay, so we're going to sweep from the bottom. Okay, the first y value, if I'm moving vertically, right, up and down this y-axis, right, if I'm a little ant traveling on here, right, as I'm traveling from the bottom, the first time that I see this graph is right here at y equals -2, okay, and -2 is part of the graph, so I'm going to include him, okay, but as I move up, as I sweep up to the top, right, I see these arrows. Well, what does that tell me? That means that there is not an upper limit on the y value. It means it goes on and on forever, so I can put an infinity sign there. Okay, and again, you can watch the videos that I posted to remind yourself, but you always use parentheses next to the infinity sign. You never, ever put brackets next to them. And the simple reason is that the idea of infinity, right, the concept is that it goes on forever, right? The idea of a bracket is that it's bounded or closed. So those two concepts don't go together. You can't bind or close or encapsulate infinity because by definition, infinity is a thing that just goes on forever. Okay? So if I'm going from -2 to infinity, I would rewrite that as x is greater than or equal to -2. That's how I would express that in inequality notation. Okay, let's do this one. So domain, so we want to sweep from left to right. Again, pretend you're a tiny little ant walking along the x-axis, right? The very first time you see this graph existing is right here, okay? I believe that is the value x equals 2, okay? And again, I didn't draw the arrows, I probably should have, but the idea is that this is infinite in that direction. So there is not an upper limit. If I were an ant, I would be an ant that would be walking forever and ever and ever, okay? So now let's figure out our points. So it looks to me like this function is actually defined here because there's a dot here. So I'm going to include 2 in my endpoints, okay? And again, we always have to put parentheses. We never put brackets next to the infinity sign. Okay, how could we write that in inequality notation? We could just say that x is greater than or equal to 2. Okay, so now we have to think about the range. So now instead of sweeping from left to right, instead I'm sweeping from the bottom to the top. So as I move up the y-axis, where's the first y value that I see this? Well, the first y value is right here, right? And that's actually at y equals 0. Okay, and then if I keep going up and up and up, right, this means that it's going to keep increasing. So there is not an upper limit on the set of y values or my range. Okay, so the next thing we have to decide is this point a part of my solution? And again, if I erase this here, you can see that it does definitely look like that is a point on my graph. So I'm going to include 0. And again, you always, always, always have to put parentheses. You can never put brackets next to the infinity sign. Okay, if I want to write that in inequality notation, I would just write x is greater than or equal to 0. Determining the domain of a function given an equation. There are 2 reasons that we have to restrict the domain of a function. One is that we are not allowed to divide by 0. When we try to do that, we get a value that's undefined. And the other thing is that we can't take an even root of a negative number because that results in that I thing, right? It results in either an imaginary or complex number, which is not a number that can be plotted on the Cartesian plane. So let's go through these equations and find out if there's any reason for us to restrict the domain of the function. So first we have f of x is equal to 4x plus 5. So first of all, is there anywhere where we're trying to divide by a variable? Well, it doesn't look like it. No. Is there anywhere in the function where we're trying to take the even root of a variable? Again, the answer is no. So the domain is all real numbers, or we're going to write all of these in interval notation, so it's from negative to positive infinity. All right, let's look at our next function. We have g of x equals 3x squared plus 4x minus 6. So do we need to restrict the domain? Well, first of all, are we trying to divide anywhere by any variables? No. Are we trying to take an even root of any variable? No. So again, for this function, the domain is all real numbers, or negative to positive infinity. So I'm going to do the next ones on separate pages so that we have more room to work. Let's look at h of x equals 5 divided by x minus 2. So all of a sudden we have a variable in the denominator. So we have a reason to restrict our domain. So specifically we need to say that x minus 2 can't be allowed to be equal to 0. Solving for x, we find that x cannot be equal to 2. So let's graph this idea, this concept on a number line. So let's just say, I don't know, 2 is somewhere here in the middle of this number line. Okay, so my variable, my x variable, right, my independent variable can be anything I want, but when I get to 2, I have a little hole, right? I have to skip over that. But once I get past 2, right, x can be any number that I want it to be. Okay, so let's take this number line and see if we can translate it into interval notation. So remember, this left pointing arrow represents going in the direction of negative infinity, while the positive arrow represents going in the direction of positive infinity. So how can we put this together into interval notation? Well, we're starting at negative infinity, and then we go to 2. However, 2 is not part of our domain, so we have to put a parentheses next to the 2, indicating that we exclude that 2. Then we pick up on the other side and go from 2 to infinity, again, not including the 2. Then what we do is we usually write this union symbol to unify or put together 2 disjoint intervals. So that would be our final answer. Negative infinity to 2, union to infinity. That is the domain of this function. Let's look at the next problem. So if we look at k of x equals 7x over x squared minus 9, again, we have a possibility of dividing by 0. So we have to take that denominator and say, wait a minute, we can't let that be equal to 0. X squared minus 9 is a difference of squares, which can be factored as x plus 3 times x minus 3. So we take both of those linear terms and say that they cannot be equal to 0. And solving both of them for x, we say that x cannot be equal to either negative 3 or positive 3. So let's draw that picture on our graph. So let's just say 0 is somewhere in the middle here. And so we have 1, 2, 3. This is 3 right here. And 1, 2, 3. This will be negative 3 right here. Okay? So if we color in our number line, right, it can be anything we want to except for when we get to negative 3, we have a little hole. Right? And then we keep going. We have another little hole when we get to positive 3, and then we keep going on to infinity. So let's write this in interval notation. Again, I invite you to remember that the left pointing arrow represents negative infinity, and the right pointing arrow represents positive infinity. So let's build our interval. So we have negative infinity to negative 3. Again, putting in parentheses to indicate that we have to exclude negative 3. We use our union symbol to join disjoint intervals. So then we have negative 3 to 3. And then we have 3 to infinity. Again, making sure we put parentheses next to every single number, right? Because we're excluding both 3 and negative 3. And of course, we always have to put parentheses next to positive or negative infinity. So that would be our final answer. Let's look at this next problem. So we don't have any division, we don't have any variables in the denominator, so that's not a problem. However, we are trying to take the square root of something, right? So we can't take the square root of a negative number, so we have to restrict x minus 7 and say that it has to be greater than or equal to 0, right? It can be 0, right? The square root of 0 is 0, that's fine. It can be positive. I can take the square root of any positive number that I want to. But again, if I take the square root of a negative number, it's going to give me a non-real answer that I can't plot on an XY graph. Okay, so let's finish solving this inequality. So we have x is greater than or equal to 7. Okay, so let's draw that on our graph here. Let's say 7 is right here. Okay, greater than or equal to 7, that means we're including 7 as our endpoint. He's part of our solution. Right, greater than or equal to, right? Remember this arrow points to the right, so I know I'm shading to the right. I can translate this to in an interval notation by putting a bracket next to the 7, and then remember I'm going towards positive infinity. So this would be the domain restriction for that function. Let's do another one. Again, we don't have to worry about dividing by 0 here. There is no variable in the denominator. However, we do have that root problem, right? We say that 3 minus x has to be greater than or equal to 0. Again, it can be positive. It can be 0 because the square root of 0 is 0. What it can't be is it can't be negative. Okay? So this one's a little bit more challenging. So first I'm going to subtract 3 from both sides. If you're like, hey, Professor Lumen, why aren't you adding 3? Well, look at the sign in front of the number. 3 is actually positive, so be careful. Okay, also remember this negative sign belongs to the x, so I don't bring down x, I bring down negative x. So be careful with that. So we're not quite done yet because we have negative x is greater than or equal to negative 3. What we have to do is we have to divide both sides by negative 1. Okay, so we get x and 3, and you have to remember what happens to our inequality sign when we divide by a negative. Well, what happens to our inequality is that it switches orientation. So our final answer is x is less than or equal to 3. Okay, so I'll post a remedial video if you forget how to solve inequalities and the extra rules that go along with inequalities that don't apply to solving equations. Okay, so let's go ahead and graph this. So let's just say 3 is somewhere here in the middle. Okay, less than or equal to 3, that means I'm including 3 in my values, and less than, this is pointing to the left, so we go to the left, remembering that the left pointing arrow indicates negative infinity. So my interval is from negative infinity to 3, including the 3. So the last part of this video is that we need to learn how to evaluate functions. Let's begin. F of 2 if f of x equals 2x minus 3. So f of x equals 2x minus 3. So if I want to find f of 2, okay, then what I'm going to do is I'm going to build a little nest everywhere I see an x. I'm going to put parentheses to open up a spot for my for that 2. Again, wherever I see the x, in place of x, I'm going to write a 2. So we can say that f of 2 is equal to 2 times 2. Well, that's 4 minus 3. So f of 2 is 4 minus 3. Well, that's 1. So this is our final answer. Again, I just want to encourage you to remember that this is our x value and this is our y value. So if you were to write this as an ordered pair, the ordered pair would be 2, 1. Let's do some more examples. Now we want to find g of negative 2 if g of x is equal to 1 plus 2 absolute value, 3x minus 4. So again, we have g of x is equal to 1 plus 2 absolute value, 3x minus 4. So we want to find g of negative 2. So the first thing I'm going to do is I'm going to copy this equation, again building a little nest for my x value. Okay, what's going in place of that little, in place of x? Well, just negative 2. Okay, so at this point we need to remember order of operations. Please excuse my dear Aunt Sally, right? So these lines are not parentheses or brackets, this is absolute value. Okay, and if you forget, well, what is the absolute value of a number? Well, the absolute value of a positive number stays positive. The absolute value of a negative number becomes positive. And if you have the absolute value of 0, it's just 0. Okay, so again, please excuse my dear Aunt Sally, we have to start inside these, the absolute value signs, because even though they're not just parentheses or brackets, they actually do something, they change the numbers, they're still treated as grouping symbols. Okay, I want to encourage you to remember you cannot add 1 plus 2 first, right? So again, please excuse my dear Aunt Sally, we have to use parentheses or grouping symbols. We have to evaluate those first. So we have to do what's in the absolute value signs first. Okay, so another piece of advice I have for you is to always write the whole equation every single time, even though it's a little bit of a pain. Okay, so 3 times negative 2 is negative 6, and we bring down the 4. Okay, let's keep going. So we have 1 plus 2 absolute value, well, negative 6 minus 4, you can put that in your calculator, gives you negative 10. So remember what we went over up here, right? If I have the absolute value of a negative number, it becomes positive. So what does that mean? Well, that means the absolute value of negative 10 is positive 10. Okay, and these are joined, in case you weren't sure, these are joined with multiplication. Okay, so g of negative 2 is 1 plus 2 times 10. Again, going back to your order of operations, we have to multiply or divide before we can add or subtract. So again, we cannot add 1 plus 2 here. We can't do that. Instead, what we have to do is we have to do our multiplication first, and last but not least, then we can do our addition. Okay, so to conclude, g of negative 2 is equal to 21. That is our final answer. And again, I encourage you to remember that negative 2 is your x value, 21 is your y value. So if anybody asked you to write that as an ordered pair, you could write it as the ordered pair negative 2, 21. All right, let's do another example. We have h of negative 4 if h of x equals 2x squared minus 3x plus 1. So we want to do h of negative 4 is equal to 2x squared minus 3x plus 1. Okay, notice this time I just went ahead and built nests for my variables. Okay, and in each of those sets of parentheses, I'm going to put the negative 4. It's extremely important that you use parentheses for many reasons, but especially when you're working with negative signs. Okay, so remember your calculator. Even if you have just, a basic scientific calculator, you don't need a graphing calculator, right? If you use parentheses, you can type in parentheses negative 4, close parentheses squared, right? Well, what is negative 4 quantity squared? Well, let's remember, that means, right, that is saying that we have negative 4 times negative 4. That's going to give us a positive number, okay? So anytime I see mistakes on these sorts of problems, usually the mistakes that I find are sign problems, right? Sign errors, so be careful. Okay, so again, negative 4 quantity squared is positive 16, not negative 16. Again, be careful. Okay, then we have a negative 3 times a negative 4. That's going to give us positive 12 plus 1. Okay, another mistake that I sometimes see is order of operations errors, right? So we went ahead, we did our exponents, right? We evaluated our exponents. We have to do that first. The only operations now that we have left are multiplication and addition. Again, we have to do our multiplication before we can do addition or subtraction. So 2 times 16 is 32. So we have 32 plus 12 plus 1. So that is going to give us 44 plus 1, or 45. So we can say that h of negative 4 equals 45. That's our final answer. Again, if anybody asks you to write it as an ordered pair, this negative 4 is my x value, 45 is my y value, so I'd write it as negative 4 comma 45. All right, this one's a little bit different. Take a minute, pause the video, look at it, and see if you can see what's a little bit different about it. Well, you might notice that my new x value, as it were, right, isn't a number, is it? No, instead of a number, it's a variable. So I don't want, f of 2 or f of 0, I want f of t. So what does that mean? How do we do this? Well, we're going to do exactly the same procedure, okay, where we build little nests for our new values, right? And instead of replacing the x with, any sort of number, we're just going to replace it, in this case, with t. So my final answer is that f of t is equal to 2t minus 3. And because t is another variable, right, meaning we don't know what it is, nobody told us, that's as far as we can go. That's it, okay? And if you had to write it as an ordered pair, you could say that your x value is t and your y value is 2t minus 3, if you wanted to do that. But again, this is fine for a final answer. All right, let's do another one. This time we have f of 4x if f of x is equal to 2x minus 3. Okay, so once again, I'm going to build a little nest for my x value. And what are we going to replace x with? Well, we're replacing it with 4x. Okay, so we have f of 4x. All right, again, going back to our order of operations, 2 times 4x is 8x. So f of 4x is just 8x minus 3. And again, x is a variable, right? I have no idea what x is until somebody tells me. Nobody told me, so that's as far as I can go. And again, if you had to write that as an ordered pair, you could write it as 4x comma 8x minus 3. All right, let's do one more of these. So now we have f of x equals 2x minus 3, but we have, or we want to know what is f of x plus 1. Okay, so again, I build a little nest for my new value. And that new value, the thing that's going to replace x, is just x plus 1. Okay, so then if we look at this expression on the right side of the equation, right, hopefully this looks a little bit familiar, right? And we know that we can just use the distributive property. So 2 times x is 2x, and 2 times 1 is 2. Okay, let's bring down everything else. So we have f of x plus 1 equals 2x plus 2 minus 3. Hopefully you realize these are like terms. 2 minus 3 is negative 1. So we can say that f of x plus 1 is equal to 2x minus 1. And again, if you had to write that as an ordered pair, it would be x plus 1 comma 2x minus 1. Last but not least, we need to learn how to find the output of a function from its graph. So the first bullet point asks us to find y equals f of negative 4. So what we need to remember here is that this negative 4 that they're giving us is the x value. Because remember, we write f of x, and in this case, x is being replaced by negative 4. So what is the value of the function when x equals negative 4? Well, x equals negative 4, that's a vertical line right here. So let's go and see where that vertical line crosses the graph. Well, it looks like it crosses the graph at y equals 1. So the answer here is y equals 1. And if we had to write this as an ordered pair, we would write x is negative 4 and y equals 1. But I'm fine if you just want to write this for your answer. All right, the next one says y equals f of 0. Again, remember 0 is your x value. So 0 is your x value. So here's x equals 0. So here is the y value where the function crosses that line. And it looks to me like it's y equals 5. And again, if you had to write that as an ordered pair, you'd say x is equal to 0, y equals 5. So the next bullet points are asking us not to find y, but to find x. This is saying find x if f of x, or y, equals 4. So let's draw a line at y equals 4. So this is the line y equals 4. So as you can see, this line crosses the function at not one, but two different values, or two different places, right? So this is the point x equals -2. This is the point x equals +2. So how do we know which one they want? Well, they tell us, right? In the first bullet, they say find x if f of x is 4 and x is less than 0. Which of those two values have x is less than 0? Well, this is the negative one, so this would be x equals -2. So that ordered pair would be -2, 4. Then the next one asks us for the positive value of x, which is +2. So that's x equals +2, and it gives us the ordered pair 2, 4. Okay, the last two bullet points ask us the same sort of question, but this time they say, what if y is -4? So y equals -4 is this line down here. And again, you can see the line y equals -4 crosses the function at two different places. One, it crosses the function at -6, x equals -6, and it also crosses the function there at x equals +6. So again, they specify which one they want, right? So in the first bullet point, they want x is less than 0, so that's going to be our negative solution. And then they want the positive solution, so that's going to be x equals +6. And again, if I had to write these as ordered pairs, this would be -6, -4, and this would be +6, -4. So let's look at the second example. I want to encourage you to pause this video, try to do the bulleted questions on your own, and then unpause it to see if you are correct. So the first bullet says find y equals f of 4. Again, I encourage you to remember that this 4 is the x value, not a y value. So x equals 4 right here. This is the line x equals 4. So what is the y value when x equals 4? Well, it's right here. That's where the red line crosses the blue line. So if we go over to our y-axis, we can see that this gives us the value y equals -4. And if I had to specify what is this ordered pair, well, that ordered pair is x equals 4, y equals -4. All right, let's do the next one. It says y equals f of 0. So that 0, again, is the x value. So x is 0 right here. And where does that red line cross our blue function? Well, it crosses it at y equals +4 right there. Okay, so if I had to write this as an ordered pair, it would be x equals 0, y equals +4. So the next three bullet points actually ask us to find x given y. Okay, so it says f of x equals 4. That means y equals 4. Our y value is 4. So I just graphed the line y equals 4, and you can see that it crosses our function right here at what? At x equals 0, isn't it? So this is x equals 0. So this is the point 0, 4. Notice that these are the same, right? These are actually the same ordered pairs, but in the first bullet point, we were given x and asked to find y. In this bullet point, we were given y and asked to find x. Okay, but again, they result in the same location on the graph, the same ordered pair. All right, the next one says find x if f of x equals -4. So here's the line y equals -4, or f of x equals -4. And similar to last time, we can see that it crosses this function at two different places. It crosses it at x equals -4, and it also crosses it at x equals +4. So how do we know which one they want? Well, the first one, they want the positive value, right? So this would be x equals 4. And the second one, they want the negative value, so that would be x equals -4. Okay, and again, if we wanted those ordered pairs, this would be +4, -4, right? X equals 4, y equals -4. And the second one would be x equals -4, y equals -4, right? And again, just go back to your graph, right? Think about what is the ordered pair associated with this point. Well, x equals -4, y equals -4. That's the ordered pair. What is the ordered pair associated with this point? Well, it's x equals +4, y equals -4.